Hi friends, welcome to Chinmay Creative and Content Maths Academy, that is Triple CMA or CQMA. In this video we are going to discussing about example 3 of CBSE class 10th chapter 1 real numbers. This question is about again same thing like that we are going to uh, proving the relationship between the positive odd integers as a 4q plus 1 or 4q plus 3. What is the question? The question is like that. Show that any positive odd integer is of the form 4q plus 1 or 4q plus 3 where q is some integer. Okay, we are going to understand and solve this one. How? So already I discussed it in last example 2. We have some clues in the questions only. So this is we are going to solve by Euclid's division lemma. Correct? I put its new more creative name as a 4 friends lemma. Okay, what it says, given positive integers a and b, there exists any q integers q and r. Means if any two friends are there, two friends a and b, for them two more friends available in the world as a q and r, and relationship between these four friends given by a equals to bq plus r equation. That is the Euclid's division lemma. In this, r is less than b and greater than or equals to 0. This is a very important relationship. On this basis, we are going to solve this one, prove this one. Okay. So, what I told in the last class, this any positive odd integer, we have to let the term only as a first friend. Our first friend is a. Let a be the positive odd integer. Okay, and I required one more friend. These four friends. First I need two friends. What is the b? See, in the question this is the resembles bq plus r, RHS part. So we can take b as a 4 here. Let a be the positive odd integer and b equals to 4. So what is the relationship between our remainder r and b? R is always less than b. So here what is a b? 4 means r may be 0 or 1, 2 or 3. So 4 possibilities are there. It should be less than b, okay, not equals to b, and greater than or equals to 0. Yes, it is equals to 0 and greater than 0 also, no issue. Okay, so we are getting 4 remainders. So we are getting 4 cases. First case, when remainder is 0, so we have to solve this one in case wise steps. So when case 1, when remainder r equals to 0, what we have taken, two friends a and b. A one more positive integer and b is 4. So apply the lemma here. What happens? A equals to 4q plus 0. R is 0 here. Okay, what is lemma? A equals to bq plus r. This is our lemma, right? Okay, so we can write a, b is the positive odd integer, then a equals to 4q plus 0. It becomes what? A equals to 4q. So this one we can write as a 2 into 2q. So keep this one like this only. Go to case number 2. Okay, case 2, a remainder may be 1. So how to write? Apply the lemma here. It becomes a equals to bq. At the b we have taken 4. So 4q. Q is any integer. plus remainder is 1. Okay, keep as this one as equation number 2. Again go to case number 3. R equals to what? 2 now. 2. So apply the lemma here. It becomes A equals to 4q plus 2. We can take 2 is the common here. 2 into 2q plus 1. Okay, that's it here in case 3. And what happens for case 4? A remainder is how much? Now 3. How many remainders are there? That many cases we have to write down here. In each case apply the lemma. 4 friends, this first friend, second friend, this is the third friends, and q they given any integer, so write the q as, take as it is. Now what happens applying lemma? A equals to 4q plus 3. We can't take any common here, just leave it. Okay, so here case 1 and case 2 are multiples of 2, or both are divisible by 2. Means numbers, even numbers means what? Always they are divisible by 2. Okay, and case 2 and case 4, what we got? A equals to 4q plus 1, 4q plus 3. See, here this one also, what happens? Here we can write this one as a 2 into 2q plus 1. 4q means 2 into 2q, 2 to the 4, 4q plus 1. So this is the multiples of 2 plus 1. Always we will get odd numbers. Okay, here also this 4q we can write as a 2 into 2q plus 3. So multiples of 2 always getting even number. For this even number we are adding again odd number, like this. Here also we will get resulting number is always odd number. So we can say, as per the question, we proved every positive odd integers, right? See, positive odd integers. These positive odd integers are in the form of 4q plus 1 and 4q plus 3. Yes, 4q plus 1 and 4q plus 3 is the enough. And the conclusion, as any positive odd integers is of the form 4q plus 1 or 4q plus 3, where q is any some integer. When put here q equals to 0, what happens? 4 0 0 plus 1, we get 1. Here also put a equals to, okay, make it 2 tables here. Again 2, 4 into 0, 0 plus 3, we getting a equals to 3. When q equals to 1, here 4 on the 4 plus 1, we are getting 5. Here 4 on the 4 plus 3, a equals to 7. Q is any integer, right? 4 to the 8 plus 1, we are getting 9. Here 4 to the 8, 8 plus 3, 11. So we are getting always even number. So we can write even numbers, odd numbers. So we can say positive odd integers are of the form 4q plus 1 or 4q plus 3. Okay, friends. Thank you. Bye. Have a nice day.